Bonsuelo Mathletes, okay, culmination of the chapter. This is going to be, first of all, kind of a summary of what you need to know. And then we're going to talk a lot about dividing. Okay, because that's what this whole last few sections is all about. If you can't factor and it's degree 3 or greater, you divide. Okay, so let's summarize everything about polynomials. First of all, they're linear polynomials. Degree of 1, you just use SADMAP. You just get the variable by itself. Number 2, quadratic equations, degree 2. You factor by inspection. Okay, what's that mean? Greatest common factor, difference of two squares of trinomial, perfect cubes. Okay, obviously cubes are not quadratic, but okay, so what if you can't factor by inspection and it's degree 2? You use the quadratic formula or you complete the square. Most people are going to use the quadratic formula. It's just easier. Okay, number 3. All other polynomials, degrees 3, 4, 5, 6, 7. You factor by inspection. Again, what's that involve? Greatest common factor, difference two squares or trinomial, perfect cubes. Okay, what if you can't do that? So we're talking, this is what this chapter is about. Degree 3 or greater that you can't factor by inspection. So it's not new in the sense that we've never done it before, because I've been talking about this for probably about a week or so, but it's new this chapter, and you use the factor theorem. And what is that? Divide. That's it. You divide, right? And the divisor is a factor of the dividend, okay? When? If you have no remainder, if the remainder is 0. Okay, that's the idea. The divisor is a factor of the dividend if the remainder is 0. And I've been saying that now for quite a while, okay? Don't lose sight of that, because there's a lot of other stuff here besides that, but all of the other stuff doesn't matter. You can do everything else perfectly correctly, but if you're not dividing and getting a remainder of 0, you're not doing what you need to be doing. Okay, so let's take a look at this. There's going to be several things here. All of it depends on the factor theorem. Division and getting a remainder of 0. Okay? But there are going to be other ideas here too, most of which I've already talked about. One's going to be completely new. Okay, so again, don't forget that the factor theorem, dividing and getting a remainder of 0, is the main idea here. Okay, but there are also 3 other things you need to know. All right, there's the remainder theorem. Quite frankly, you can skip the remainder theorem. Okay, I'm not going to go through it. You don't need it. I put it on here in case you want to look at it. Be my guest, but it's not necessary to know that. Okay, the conjugate root theorem. We've already gone through that. All right, that is if a plus bi is 1, 0, then a minus bi is the other 0. Now, what's completely new, I've never talked about before today, is this, the thing called the rational root theorem. Okay? And here's the idea. Just listen to this. Don't write this down. I've asked you questions such as this. Okay? Don't write this down, though, because we're not going to do this problem. Factor P of x equals x to the third plus 3x cubed. Do not write this down. 3x squared minus 11x plus 2 if 2 is a 0. Or I might have said x minus 2 is a factor. Okay, what are we doing new today? Because we've already done this. We've done this many times. Okay, what are we doing today? This is what we're doing today. I'm going to take this out. And I'm just going to say factor it. Okay? I'm not going to give you one of the zeros. Up until now, I've been giving you a 0, at least one of them. Okay? So what do? Well, you try and factor by inspection. But this doesn't factor by inspection. Okay, so what do? And if you don't know, if you're not immediately saying to yourself, divide and get a remainder of 0, then you don't know what you need to know. Okay, and you could say, well, but I have nothing to divide by. And I'm going to say, yeah, so guess. Just try numbers, okay? Now, how long could this take you? This could take you 2 years. Because let's say the numbers, something like, let's say the zeros are all really bizarre, all right? It's going to take you forever to guess them. So that's where this comes in, the rational root theorem. The rational root theorem, be very careful here, it doesn't necessarily give you any roots. It just gives you ones to try, so it's not just a total guess and check. In other words, the rational root theorem is going to say, you know what? If there's a rational root, it's going to be one of these numbers. And I'm going to give you a handful of numbers. Now, are any of them necessarily going to work? No. But if there's a rational root, it's going to be one of these. Well, it's better than just total guess and check. Okay? So that's what this is going to do for us. It's going to give us, the rational root theorem is going to give us numbers to divide by when you're not given any numbers to divide by. You're just going to have to come up with a list. Now, how do you come up with this list? We'll get to eventually. Okay? But that's what's new today. So I'm going to kind of blitz through the other stuff that we've already done, and I'm going to spend my time talking about the rational root theorem. Okay, I hope you did not write this down because we're not doing this today. Okay? All right. So the remainder theorem. You can take, if you wish, your pen and go cross it out. If you want to read it, you may. Be my guest. But you don't need to, okay? So if you want to cross out the remainder theorem, that's fine. I don't want to spend time talking about it. For our purposes, it's just not that big of a deal, okay? It's fine if you want to do it. It's fine if you don't. Okay, conjugate root theorem, okay? This is, again, if a plus bi is one root, then a minus bi is one root. So there you go, okay? You've done that before. Okay, here's the new thing, the rational root theorem. And before I tell you how to do it, you have to know what you're doing. Again, it's nice to know how to do something, but you have to know like why you're doing it or when to do it. Okay, first of all, you've already tried factoring by inspection and it didn't factor by inspection. So what are you going to have to do? Again, the rational root theorem does not solve the problem. What solves the problem? Dividing and getting a remainder of 0. And then if that happens, then you write divisor times quotient. So again, I want to emphasize it's dividing that solves the problem, not this. This just makes your job a little easier. That's all. So you don't have to guess and check things to divide by. Okay. So here's the deal. I'm going to, but make sure you understand that. So it says this only gives you possible roots. To find the actual roots, you must test this list. And how do you test this list? And if you can't answer that, you don't know what you need to do. You test it by dividing. Again, that's the factor theorem is the thing that solves the problem. All this other stuff just kind of helps and makes things easier. But it's dividing and getting a remainder of 0, okay? Only the factor theorem. And what's the factor theorem? Divide and get a remainder of 0. Only that can solve the problem. Don't lose sight of that, and it's easy to lose sight of it. Okay, so what's the rational root theorem? All right, if you have a polynomial, you have a leading coefficient and a constant, okay? The constant's the number here on the end. The leading coefficient's the one with the largest degree term. Okay, you can get a list of possible rational roots. I don't know if any of them are going to work. The only way you can know if they work is doing what? That's right, dividing and getting a remainder of 0, okay? But this is how you do it. You find all fractions P over Q. Now, how does this work? And I'm not going through the theory of this, by the way, on the video. I'll go through it in class. It's actually a very simple idea. Okay, you take the constant and do the constant first, okay? and you list every single number that could be multiplied to get a 15. So what could it be? 1 and 15, -1. It doesn't matter whether it's positive or negative, by the way. So it could be 1 and -15, -1 and 15, 3 and -5, -3. Basically, you just list every single possible factor of 15, okay? Anything that can be multiplied to give you 15, both positive and negative. So it could be 1 times 15, which is positive and -1, positive and -15, some sort of combination of those, and then 3 times 5. We'll do the same thing for the leading coefficient, okay? So what could give you 14? 1 and 14, 2 and 7, again, positive and negative. And this is what you do then. You write every fraction P over Q. Now, don't do this haphazardly, okay? This is what you want to do. Take every one of these numbers and put it over the first Q value. What does that give us? Plus and minus 1, plus and minus 3, plus and minus 5, plus and minus 15. Okay? Now what do? You take every one of these values again, and you put it over 2. So what do you get? 1 over plus and minus, all of these. 1 over 2, 3 over 2, 5 over 2, and 15 over 2. So when I put it over 1, okay, I'm not done, by the way. I got these 4. When I put it over 2, I got these next 4. Okay, and I think hopefully you're kind of getting the idea here. Now I'm going to take every one of these again and put it over 7, and I get these 4. Then I take every one of these again and put it over 14, and I get these 4. Now, what am I saying? Do any of these actually work? I don't know. Well, you tell me. Why don't I know? What haven't we done yet? Okay, and if you can't answer that, you don't know what you need to know. Okay? The only way I can know if any of these actually work is by dividing and getting a remainder of 0. Okay? Well, how many numbers is this? Okay, count them up. I'm going to give you a second to count them, and then I'll tell you how many numbers are here. And if you need to pause the video to count them up longer, that's fine. But I'm going to tell you, okay, there are 32 numbers here because there are 16 positives and 16 negatives. Okay? And what I'm saying is this. If there's a rational root, okay, it's going to be one of those 32 numbers. Well, how do you know if any of those are rational roots? We haven't done anything yet. Why not? Because we haven't divided. So you have to divide. And as soon as one gives you a remainder of 0, you don't keep dividing all the other ones. You write divisor times quotient. Okay? Now, that's it. I'm going to take one more example. By the way, obviously, I haven't done anything with this problem. I'm just showing you the rational root theorem right now. In the next video, I'll show you actually how to complete a whole problem. But I'm just going to do one more, just for the sheer joy of it, for the love of math. Okay. So, again, right now, all I'm asking you to do is list the possible rational roots. Okay? So let's take f of x equals, I don't know, 8 x to the 7th plus 39 x to the 6th minus 407 x to the 5th plus x to the 4th minus 12x squared plus, let's keep this one simple. We'll make it 5. Okay, let's take all the factors of 5. Well, it'd be plus and minus, and you can use parentheses here, 1 and 5. Okay? Let's take all the factors of 8, and it'd be plus and minus. Well, you could have 1, 2, 4, and 8. Because it could be 1 times 8 or 2 times 4. Okay, so let's make a list of all the fractions, p over q. So we'll take every value for p, 1 and 5, and stick it over 1. So we get 1 and 5. Then we'll take every single one of those and stick it over 2. So we'll get 1/2 and 5/2. Then we'll take every one of those and stick it over 4. So we'll get 1/4 and 5/4. Then we'll take every single one of, then we'll take 1 and 5 and stick it over 8. So it's 1/8 and 5/8. Okay? And if, how many numbers are there? Not 8, there are 16, because there are 8 positives and 8 negatives. So if there's a rational root there, it's going to be one of those numbers. And how do you find it? You divide and get a remainder of 0. Okay? Let me show you one more, because there's just something I want to show you. Again, we're just making the list here. We actually haven't solved anything yet. That's coming up. Okay, let's take g of x, I don't know, equals, well, let's make it 6 x to the 4th plus 17x cubed plus x squared minus 9x, and let's say a minus, oh, I don't know what. We'll keep it fairly simple. We'll keep it 4, okay? All right, so first of all, let's make a list of the things that could give us 4, and it's plus and minus 1, 2, and 4. Okay, all the things that could give us 6. So it'd be plus and minus 1, 2, 3, and 6. Okay, now let's make a list of all fractions. So it's plus and minus. Now we're going to take every single one of these and put it over 1. Then we're going to take every one of those and put it over 2. So we get, notice, 1 over 2 is 1/2. 2 over 2 is 1. We've already got 1, so we don't have to put it down again. And 4 over 2, now we're putting them all over 2 right now, right? We've already done the 1. 4 over 2 is 2. I don't need to put it down again. Okay? So now let's go for 3. So I'm going to take every one of those numbers, 1, 2, and 4, and put it over 3. So we have 1/3, 2/3, and 4/3. Okay. Now I'm going to take every single one of those numbers and put it over 6. So we have 1/6. 2/6 we've already got, because 2/6 is 1/3, so I don't need to put it down again. And 4/6 is 2/3. I don't need to put that down again. So those are all the numbers that could possibly work. Okay? And how do I know if they work? If you can't say this in your sleep by now, I'm kind of scared, but you divide and see if you get a remainder of 0. And you could always ask, well, what if I divide all of these and none of them give me a remainder of 0? Well, there are still zeros to this. We just won't be able to find them. Okay? All right. So next time we'll look at what do you actually do to complete an entire problem. Have a good day, everybody.